Hello everyone and welcome to this tutorial. My name is the TDS Gamer and today we're going a scriptable object finite state machine. Please do keep in mind that this state machine will take a while to code the boilerplate code, but after that to implement new functionality will be super quick. So as you can see, we have here the state machine and it has the current state. Don't bother about the remaining state, but do follow the current status. So we do transition from state to state. We see in which state we are. We define the state in scriptable objects, or our actions and our decisions, which we do. Also keep in mind that tutorial was covered by Unity itself, but what they did is they do explain it wonderful and perfectly, but they made a bigger game. So what I want to do is try to visualize you certain things which they didn't, but they still explain them very nicely. But maybe for some beginners or intermediate people, it's still too hard to understand. So what I want to do is with my next tutorials and the past tutorials is try to explain things more visually. So I will do certain animations on the screen and try to explain you the flow of the code. And of course, so you understand it good. And at the end, we will also develop our small version of a game. Yeah, that's it. I hope you have some time. If you have questions, feel free to join our Discord. It's I'm always there, almost 24/7. And if I'm not there, then there are other people. Also, if you subscribe, I appreciate it a lot, since the tutorials take me also quite some time to make them. And with a simple subscribe and like, you can basically make me a bit happier. If you have any other questions or whatsoever and you don't have Discord, just write them in the comments down below. And other than that, let's start, guys, and see you the next time. So how does our state machine work? So in our scene, we have our entity game object. It could be the player, AI, doesn't really matter. And it have a component attached to it, which is the state machine. The state machine always needs an initial state, which is a state scriptable object. And inside of the state scriptable object, we have certain logic inside. So let's keep it clean. The state machine needs a scriptable object as its initial state. So that will be the state we start with. And it can transition to different other states, right? Every state is can have one or more actions, but it also can have one or more transitions. That means that, let's say we have our travel action here and our health decreases because anything happened, okay? So what we do is we check whether our health is high enough or it's under our minimum. And if that's the case, we do transition to a different state. And if that's not the case, we still stay in our current state. So let's visualize that a bit more. But that view is just to show you that we can have in a state multiple actions calling all the time, and also have multiple transitions which are different, and depending on the situation, we can transition to different states. Let's go. So we have our state machine. Our state machine have its initial state, which is the current StateSO, and we run the update state function in the update loop. The update state function will run all the actions followed by all the transitions in the loop, and the actions are void actions. So basically we run different functions depending on what we're doing. In our case here, we're travel, so we don't need multiple functions, but we have multiple transitions. For example, we have our transitions here. In case they return a true or false bool, because the transitions are also scriptable objects which return true or false depending on the if statement we provide. And in case they return true or false, we trigger a different state. So we can, for example, say if our health is over the minimum, it's a true state, so we remain in the state. But if we're under it, we change the state to the state consume, right? So when that happens, our state machine triggers another function which does change the active or the current state SO to the consume state. All right, nothing too complex, but as I mentioned, the boilerplate code is a bit more. So I hope you have some time, and let's start. Now, back in the scene, we have an empty scene, an empty project, just the scene folder with the active scene. What we need to do first is to set up folder structure so we can divide the non-state machine essential scripts to one folder, the scriptable objects to another folder, and the essential state machine scripts to another folder. So let's do that quickly, and after that we will start with our first scripts. All right, so here we are. Let's start with the non-essential scripts. They are not essential to our state machine, but they're actually essential to our gameplay, to our scene. So we do need to do them. We have 4 of them. So that way we can have a nice gameplay, and the scripts are pretty short, so I'm sure you will be able to follow. If you have any questions, just write them down below in the comments. Starting in the non-essential folder, we click right click, create C# script, and we will choose FoodStand. And we open the script. So now here in the FoodStand, I do zoom in. I hope it's good enough. That it's visible. What we will do is we do remove the start and non-update function since we don't need it, and we also remove the unused imports. What we need is a move to position, which will be a transform. That's a position where our player or entity will move to whenever we want to interact with the FoodStand. All right, so let's do that quickly. We do a header, so it's more visible in the Unity editor. We use serialized field. That means that private variables are visible and assignable in the editor. But other than that, we also do a public transform move to position, which acts like as a getter for our move to position, which is here assigned as private, but is protected from setters or from setting different values onto it. Now we also need a health recover value that whenever we go to the FoodStand, that we say, hey, recover me 20 health or 50 health or whatever. So we need a float value which represents that health amount we recover. Let's go for that as well. There we go. And we also use here the header, which is a Unity GUI function. Feel free to use it. If you don't like it, just undo it. But now we have this health recover value. We can set it to whatever value we want in the inspector. We set no default value here because let's stay a bit more flexible. And yes, so there's still a small problem here. We have this move to position, which is a transform. In our case, it will be a null point. We can give it a certain visual. We can visualize it in the Unity inspector, but I like to use gizmos to visualize it even a bit better. So for us, for now, we will use gizmo setup. Let's start with the if Unity editor function. That means we use only those variables and the functions inside if we're in the Unity editor. That way we save resources and build time or while we after the build. We use a variable show gizmos. So whenever we want to see the gizmos, we set it to true, and whenever we don't want to see them, we set it back to false. And gizmo size float we also have here. Now we need also the onDrawGizmos function, which we will put it now right over here. What we do here is if show gizmos is false, we just don't run the code under the line. But if show gizmos is true, we do run the gizmos draw sphere function, which will instantiate the gizmo at the move to position position. So wherever our null pointer will be, we will instantiate there the gizmo. And we'll give it the size of the gizmo size variable, so we can make it as big as we want or as small as we want. It really depends on your setup, how big your how much you scale your game. So actually that's it for our FoodStand script. Very basic. We just have here the health recover value and the move to position. Further in the tutorial we will do more things with it, but let's keep it for now that simple. Now back in the inspector, let's create the entity stat script quickly and open it afterwards. All right, back in the entity stat script, what we will do is we will remove again the imports and the start default functions from Unity. And what we will do is we will declare again a variable. And in our case, we define here the entity stats. You can have as many stats as you want, but in our version here, we keep it very minimalistic. So we do only need here health, right? So we create a health variable and some garrison setters for it. What will happen in our entity stats behavior is that we lose 1 health every second, right? So that is what we're going to do here. We create an update loop, and what we will do here is decrease the health every second. For that, we use health minus equal 1 times time delta time. Keep in mind, you can do that in the enumerator, but for the sake of simplicity, I will do it here in the update loop. Also, later we will have to check whether we want to go to the food stand to heal ourselves, or we want to keep walking and doing different things. For that, we do need a function which checks if we're healthy, if we're over a certain amount of health. So therefore, I have the function isHealthy, which returns a boolean. So it returns a truth or false value. And in our case, it will be we stay healthy as long as health is bigger than 80. If health gets smaller than 80, then we're not healthy anymore, and we need to tell the player or the entity to go back to the food stand and heal ourselves, right? So here we just return the isHealthy variable. I know we can make it more compact, but let's stay with the readability. Okay, everyone can do it as he wants. All right, that's it for the entity stat script. And now let's go back again to the inspector. Now back in the inspector, we still need 2 scripts more to have some functionalities in our scene before we create a terrain and our player or entity to move. We need the EntityMover script, so our player or entity will be able to move. So let's go and do that and open the script afterwards. So back here in the EntityMover script now, let's quickly remove the imports. And yeah, what will our EntityMover depend on? Is the navmesh agent from Unity. So what we will do is we say require component type of navmesh agent. We do need to import it as well, so let's do that, correct that. It comes from the Unity Engine AI package, so feel free to also import it. Since our mover will also move from certain waypoints to other waypoints, we need an array which defines our waypoints position. So let's do that as well. And what else I will do is keep track of our next waypoint position. So we also need to create for that a variable quickly. So that means that we will add as many waypoints as we want. It doesn't matter how many we have, but we need a variable to keep track on where we were the last time. You can do a random number, or you can keep really track of where you were the last time and that you want to go every time further, or you can do basically whatever you actually want. It doesn't really matter. In our case, we will also go to the next waypoint since we want to go from one to the other. And yeah, since we require the component navmesh agent, we also need a variable to cache the component inside. So let's do that as well, the navmesh agent variable. So to get the variable, we also have to get it in the start function, as you probably already know. And now we come to the functions. So our navmesh agent or our entity mover have to be able to move from one destination to the other. So we need to declare a function where we take as parameter the transform destination, which will be our destination. But furthermore, whenever we reach our destination, we want to call a callback, an action. That means you can put in that action a normal void function. So whenever we arrive at the destination, we can let something else happen, right? If you're not familiar with callbacks, let me know. We can do a tutorial on that. Keep in mind they're very essential and very, very important in terms of game development and, well, overall development. So to implement action, we need to import it from the systems package. Free to do that as well. And now we come to our logic inside the move destination function. So to make our agent move, we need to give the agent a destination and tell him that in case he's stopped, we need to set the variable to false, that he's going to be able to move again. And now we also have to tell whenever he reaches his destination. That means that we say agent.remaining distance is smaller than the stopping distance. So you have to work with those values so they fit your needs. We will leave them as default, but in certain games we want them a bit more accurate. And we have to make sure that no path is pending, right? And inside of that curly braces, so in case we're at our destination, we do call our callback. So we check if our arrived callback is null. If it's null, we invoke nothing. But if there's anything inside any function, we do invoke it. So we call the function we pass in. Let's put that in action, this our function. Since we have multiple waypoints, we have to make our player travel across them, right? So let's declare a function here, travel. And let's now call our move to destination function, right? That's what we have used it for, created it for. So here you have the move to destination function, and our destination will be waypoints from our array above. Next waypoint is the index. And since we have a callback, we have to use here our arrow function. Keep that in mind, please. Otherwise, your callback might not get invoked. And inside of here, we can actually write whatever we want. In our case, we will calculate the next waypoint destination, which will, before I forget it, please do not get scared of this modulo function. If you don't understand modulo, just Google it, learn from it. But what it basically does is that we never get out of the range of our waypoints. So that's very important since we don't want any null reference exception in our code. All right, back in the Unity inspector, we still have one class to declare. It's the consuming behavior. This one will be a bit bigger, but other than bigger, it's still going to be much understandable and nothing too complex. All right, let's get onto the last non-essential class. We do, as always, remove the unused imports, but since it's called consuming behavior, we will define here also a special behavior for our entity or player. And we need for that the entity mover and the entity stats script. So let's say a required component, entity mover and stats, which is very important for us since the mover will move our player to certain destinations, and the entity stats are for the recovery of our health, since we are going to heal ourselves, right? So what we will start with is defining the food stands. We do need an array since we will use 2 of them. So let's define that quickly. And those ones are like the waypoints. We will move to each one of them, but other than the transform, we get the food stand, so we can even later on work with the logic inside of the script. So since we move to one of them, we can, or we will need to have the waypoint logic again, also here, not only in the EntityMover. And what else we need is the private variables where we will cache the component inside, and where we get it in the start function of Unity. Exactly. So since we have our entity mover, we have certain logic within. So what we will do is we will define a function called ConsumingBehaviour, and inside of that function we will use our nice functions from our entity mover, our move to destination function, right? So let's do that quickly. And we do basically the same logic here as in the entity mover with the waypoints. Just here we take the move to position, which we defined. Let me go here, which we defined here, right? So what we will do is we will move to that position, and when we reach that position, we will first recover health from our player, and after that we will set the waypoint to the next waypoint, right? So again, here we use the modulo operator right over here. As I said, Google it, it's very simple, no words here to explain it, or basically no need to explain it. But since our consume behavior function is finished now, those functions will be used in our scriptable actions, since we want to be more flexible and not only using them on one entity. So we need more logic. In our consuming behavior, we will also have boxes, since we want not only to have one transition, but two, so you can see that our scriptable state machine is flexible. We will define here boxes. So our player will carry some boxes. We will say 10 at the start, and after a certain amount of time, he will drop those. So first off, we need a function to check if we have enough boxes. So let's declare that function quickly as well. And let's say we say we have to have more boxes than 8. If we don't have more boxes than 8, we return false. If we do have more boxes than 8, we will return true. That's what we need for our transitions from our scriptable states. For our scriptable states, sorry for that. And so whenever we don't have enough boxes, we need to pick anywhere in our map terrain more boxes up. So what we will do is we will declare a function refill boxes behavior. And inside here, we will use also our move to destination function and define this time only the first object in our food stands array. So whenever we need to recover health, we will toggle between the food stands. But whenever we want to refill our boxes, since we dropped too many, we go always to the first destination in our, or the first element in our array, right? And then whenever we reach then the destination, we do say boxes plus 2, so we increment them by 2. That should be enough. And yes, so in our logic at the moment, we don't drop any boxes at the moment, so that's what we're going to do now. Instead of an update loop, we will do here now an endless coroutine. Let's do it here, private I enumerator. Keep in mind, you have to implement it. The namespace is called system.collections. And inside of here, we will say while true, so basically an endless running loop. We say we want to wait 5 seconds, and every 5 seconds we'll drop one box. Of course, I do it here hard-coded, but you can put more flexibility inside of your components and put variables on top of that and use them here. But we will do it hard-coded for now, which doesn't affect anything from our state machine. So we do still have to call the coroutine on start, since we want to have an infinite running coroutine after we start the game. So we just call start coroutine charge boxes, which is the name of the function right over here. So those functions here we will use in our state machine, in our scriptable actions. So we just define them here in our components, and that way we can use them very flexible in multiple entities, and whether or not we can use them or not, whatever we want. So let's go back to the Unity editor now and start finally with the state machine. So back in the editor, before you get too warmed up, too much ready for the state machine, I would recommend you to still create a sample scene. I will do that quickly right now. And after that, we come back to the Unity scene and we will put those components on our entity and put some waypoints and food stands in our terrain. And then we do start with the state machine. Our scene is done, nothing too fancy. As you can see, we defined food stands right over here. I gave them a health recovery rate of 30. And there is a move to position. You can see right over here the gizmo. And we have like 4 waypoints as well set up. I did not use gizmo for that. There's no real reason for it. You can also use gizmos for that. But I gave them like those default icons. And our entity, whenever you just import the consuming behavior, he will end up importing the rest of your scripts since you used the require component function of Unity. Here we assign those 4 waypoints and here the 2 food stands. That's all we need. And now let's start with the state machine. Maybe before we do that, we can start the scene. You can see our health is going down, and if we set the inspector to debug, we can see our boxes also decrease, right? 9, and then our health is decreasing as well. So that's working for now. So now, after saying it so many times, let's start with the state machine. Now, since we start with the state machine, I would say we start with action. So let's create a new script and call it BaseActionSO. All right, so that's a base action scriptable object. And there will be nothing special to do inside. Let's open it up quickly and put our IntelliJ up, zoom a bit in, let's clear the imports. And now there will be nothing special inside other than an abstract function, void act, which takes our state machine as a parameter. So we need to put or set the class as abstract to use abstract function. But what we will do here is whenever we call the act function, we take a state machine in account, which will run the action. Simple as that. Now let's go back to Unity and create our finite state machine. So let's go back in here. I think you can't see that because I need to make my transition smoother. There we go. So now we have an error because we have no state machine created yet, but we will do so now. In the core folder, right click, create C# script SOFinite State Machine. All right. Now the error will be gone in a second. There we go. And let's go now to the state machine and let's do some coding. All right, now in this state machine, we do remove the default things we always remove. And as you already have done, we have created the entity mover, the consuming behavior, and our entity stats. Each one of them have different logic for different behaviors of our entity. So we do need them in our state machine. We do need the references to them. So let's do that quickly now. We say 3 times require component type of and our 3 components. That means that whenever we import or whenever we attach our game object, our script to our game object, all the other scripts will also get imported. So we are ready to go only by applying one class to our entity. Now we need to declare 3 variables for each one of those components and obviously make a getter as well for them since we need to get them later on in the script. And we need to assign them on start whenever the game starts. So let's do that as well quickly. So now we have nothing special here. We have our 3 classes, our components, we get them and we cache them. Now, the state machine needs a state, right? I mean, it's a state machine, so we need a state at start, which will run its functions. and depending on what is happening inside of the state, it will change its state to another one. So it makes a transition. And the transition can happen depending on a decision. So you already kind of can understand the state machine. If we have a state, it needs to make a decision for a different transition. Super easy, super simple. So here we will have another script. It's our first scriptable object. It's called the current state. It will come from the StateSO scriptable object class. So we do need to create it right now. So let's go maybe back to the Unity engine. Let me do that quickly here. And we go back to our scriptable object finite state machine. And we do right click on, let me see, that's our scriptable objects here. Core. All right, so I forgot one folder right over here, but no, we did not. I'm sorry, my mistake. So what I will do is I will right click here on the scriptable objects, click create C# script, and we'll create this StateSO script. Let's go back into Unity now, into the editor. So now in the editor, we have created our StateSO. So let's remove quickly the default things we always remove and change the state scriptable object from mana behavior to scriptable object actually. So to be able to create a state, a scriptable object, we do need to create an asset menu, right? So we have to go over the top of our class and write create asset menu, and then we have to define a file name, which will be the name after creating the file. You can just also leave it empty, it doesn't matter, or you just don't need to apply it. I just did it. And then there is also the menu name, which is important, that you definitely will need, because we will right click on the Unity editor and we will go over to the StateSO Finite State Machine, and then towards the state to create a state. So let's keep first the state pretty simple. It's not complicated. The logic behind it is pretty simple, but let's go step by step is what I want to say. Let's create first an array of actions, right? So that array is the array we will execute all the time if this state is active. So in here you will put your scriptable actions, scriptable object actions, and those will get executed every update frame. Yeah. So let's create a function for that as well. So here we create a function update state, and we take the state machine. That way we can tell a state machine to run a function which loops through all the actions and executes them. So we will do here, do actions. So we have a function that will be the function which will loop over all the actions we defined up there in the class, and then we create the function, do actions, we take as a parameter also state machine, so we do know which state machine is running those functions, and we now do the for int loop, and we say for each action in action. Well, we can do this as a for each loop. Let's keep it simple in a for I loop, or for int I loop, it doesn't matter, however you call it. But what we say is we loop one by one through all the actions in our array through, and we call the act function. The act function, as we had before, is a void. That means that we can put there whatever logic we want, but we will call it all the time. That way we can create now our first action, which will be the travel action. So our entity or player will move from point A to point B. So we will trigger the first action over our travel behavior. All right, so let's go back to the Unity editor, and let's do that quickly, because this is the first nice thing we can do right now is we can create our first real action. Okay, so inside action, maybe move the base action script out over scriptable objects. So we will have here all base and abstract scripts, and inside those folders you will have your real action scripts. So let's create another script. Right click, create C# script, and create the TravelActionSO. All right, let's open. So now back in the TravelActionSO, let's remove those defaults functions again and no imports. So TravelActionSO will come from the BaseActionSO since it's going to be a scriptable object. So we do that, and since BaseActionSO is abstract and we have in there an abstract function, we are forced to implement it. So let's do that as well quickly. Now the act function will get looped non-stop as long as the action is active. So make sure your logic is good. And since that's going to be a scriptable object, we also have to define the asset menu. So let's do that as well quickly. So in the act function of the TravelActionSO, we will call the travel function right over here. So our player is going to travel. Simple as that. So what we do is we remove the throw system not implemented exception and we change it for machine.EntityMover.travel. That means that we will, since our StateSO is calling the act function all the time, we do call the travel function in our EntityMover as well. So that's going to be our first state. Let's first go back to the Unity editor and try that out. Okay, base in the editor. Here's the scriptable objects folder. Let's create another folder called actions. And inside of actions, we do want to create an action. So we right click, create SOFinite State Machine, and we only have state. So I have checked that before. I forgot one small thing, so bear with me. Let's go back in the editor. And in the editor, you can already see that our BaseActionSO doesn't derive from scriptable objects. So we have to change that quickly, and that should be it. So let's go back out of the editor and now click right click over here after Unity compiles. There we go. Create SOFinite State Machine actions TravelSO. So let's keep the name TravelSO. Click on our entity, and now we do have to go into core and give our entity the finite state machine. And here we do want to get a state. So what we do is we create another folder in our scriptable objects called states. And inside here we will have different states depending on whatever we want to do. So we create a new state now and we call it entity state. Or let's call it maybe state initial and state travel. Yeah, travel is fine. Okay, so inside our state, we take actions. So what we will do is we will click one and we will get the travel action. So basically by that, we tell the state to be a travel state. Of course, there are still the transitions left. So you can say, hey, in case of having low health or losing enough boxes, go and heal or get some boxes. But we will do that after this step since we want to keep it a bit clean and simple for understanding. So let's go on top of our entity now, open the selection right over here and put the state travel inside. Now we press play and our entity should be able to move, which is not true because here as well we have to open the finite state machine since it's also not complete. And inside of here, we do have to still call the function. So I did forget that quickly. So let's add an update loop. Click current StateSO and update state. And we take this state machine as the parameter. Back here, just to refresh, you have here the StateSO, and the StateSO have an array of actions. And he will call all the actions all the time. And Yeah, until we do a transition, of course, right? So we do that. And in our state machine, we call the update state function where we do loop through the active states, or to the active actions, I'm sorry. So now back in the Unity editor, we're back in here. I press play. Let's go back to the scene view. And we do still have one problem. And the problem is our nav mesh agent will not move. Why? Because we still have to bake it. So what we will do is we click on the terrain, assign it as static, and we change it only to this object. And now we go under Window, AI, Navigation, Bake, and we bake. And now we have this bluish area. That's the area where our nav mesh will move on. And now finally, when we press play and we move our scene here, you can see our nav mesh agent does move from point A to point B. We can make our nav mesh agent faster or slower, depending on your nav mesh agent settings. Feel free to change them as far as you want. Okay, there we go. So our first action is working in our state machine, and you can see right over here that we're in this travel state. So what's left? So left are transitions and decisions, because in our case, in terms of the entity stats and the consuming behavior, where inside we have our boxes, we have to say, or we have to question our state machine. In case of having less health, go and heal. So that's what we're going to do now. So let's start with the decisions, or with the transitions first. No, decisions is good. So we click right click here, create C# script, BaseDecisionSO. Let's go now back to the Unity editor, to our IDE. So open the script up. So script open, base decision. Since it's going to be a scriptable object, we do remove again all the stuff we always do, and we say base decision derived not from money behavior, but from scriptable object. And inside of that class, it's going to be again an abstract class, since we want to be flexible. So what we will do is we create an abstract bool function, which will be called decide. This function will determine whether we stay in the active state, or we transition to another state, or we transition from the active state to whatever. So that's really the transition function which decides when and what to do. So since it's an abstract function, we also have to set the class to abstract. Let's do that quickly. There we go. So now, since we have the BaseDecisionSO done, we still have to add the transition. So we have decisions, actions, and transitions. So let's do that quickly now. Let's go back to the Unity editor. So back in the Unity editor, we want to add the new transition script in the core folder. So we right click here, create C# script, and we call it transition. That script will be storing the active decision we have to take, and whether it's true or false, we will do or call a different state, or just stay in the same state. So let's open that up. There we go. Back in the transition script, we're going to remove again all the boilerplate code. And what we will do is this transition class will be a class, non-money behavior, non-scriptable object, just basic class. So to access the variables in the class, in the inspector, we have to serialize the class. So we will do that, and therefore we have to import the system namespace. Also, we have to remove the Unity engine import, since we don't need it. And what will we have inside the class will be the BaseDecisionSO. That SO will decide whether it's true or false. If it's true, we will change to this state, or we will stay in the state. And if it's false, we will stay in the state or transition to another state. So basically, the BaseDecisionSO will say true or false. Whether it's true or false, we will change the state to another state, or stay in the state where we are at the moment. Now let's do our first decision. Therefore, we have to go back to the Unity editor again. So now, again, back in the Unity editor, we do create our first decision. So let's create right-click, create C# script, and let's start with our health points. So determine when our health points are smaller than required, then we do go and transition to our new action, which we will create afterwards, which will be the ConsumeActionSO. And if our health does stay in the range where we can keep traveling through our waypoints, we just return. So let's call the decision HealthyDecision.cs, and let's open it up. So back in the editor, as always, we remove the boilerplate code. So let's do that quickly now. And since it's a decision, we do derive from the BaseDecisionSO. And what the BaseDecisionSO is doing is it's forcing us to implement the decision function. So that's what we're going to do now. And since that's also a scriptable object, we will have to create the asset menu here. So we will put it into the decisions folder this time. And yes, so let's go to the decide logic. So we need to remove the throw system runtime exception, and what we will do here is determine whether we're healthy or not. So as you can remember, we have done this in our EntityStats script. So there's nothing special to do other than just create a boolean and get from our entity stats the isHealthy function. Whether the function returns true or false, we do different things. So in our logic, we're healthy as long as our health is bigger than 80. And when it's smaller than 80, we are unhealthy. So what we will do here is we do implement the function, cache it in the bool, and return it. That's for the readability. Of course, you can code it more compact, but let's keep it as it is now. And yes, that's it for our decision, but we still can't take any decisions. Why? Because we still have to implement it in our StateSO. So let's go back to our StateSO and implement those. So I'll right now with you. So what we will do is we'll create an array of our transitions and call transitions. Here inside, we will have our, basically transitions. So whenever we run those actions, we also go through our transitions and ask ourselves, hey, can I transition to another state? So for that, we need to create another function. Let's create a private void check transitions and take, of course, as always, our finite state machine inside. And yeah, so what we do here is we create a for loop, and we loop through our transitions as mentioned before. Sorry for that. And what we will say is we will create a boolean, decision succeeded, and we will say transitions I, so for each transition, BaseDecisionSO decide, and it will take our state machine, right? So that way we can say in our transitions, the BaseDecisionSO, whenever we access it, what we do is we go inside, we take the decision.so, and we ask ourselves, hey, can we transition true or false? So in that case is, if it's true, we say machine.transition to state, and then transitions I true StateSO. All right, so we say here, state machine transition us to our state true state. That means that we transition to this state. Otherwise, we transition to the false state. That means if the decision is true, if we are still healthy, or well, let's say if we're unhealthy, we transition to the state go and heal yourself. And if we are still healthy, we stay. So in that case, we also say transition to the false state, because of course it's not going to be always the same logic. So you don't always want to state if it's false, but you also don't want always to transition if it's false. And the same story was true. So the transition to state function will be declared in our state machine. So let's go over to our state machine quickly, right over here. And what we'll do is we create this public void transition to state, yeah? And we take a StateSO as a parameter, which will be the next StateSO. Okay, and we say if next StateSO, so if the next state we want to transition to is not remaining state, remain state, no, let me, yeah, okay, so we still have to declare it, but let's say remain StateSO, then current StateSO is equal to next StateSO. Okay, so we still have to declare state, which will determine whether we want to stay in the current state or not. So let's do that quickly as well here. So last field private, I just mistyped here. And it's also a StateSO, and it's going to be the remain StateSO. All right. So what we do here is we give a new state to our state machine to transition to. And if the next state is not equal remain state, we just transition. So we don't stay in the same state, but we transition. We could also say it's not null, but let's keep it clean as in the Unity guidance as well. So now we have to go to our StateSO, and I think I missed here transition to state. Yeah, I missed transition. Okay, yeah, that's I just wrote it wrong, so let me just correct that. Okay, so that way we can go back to our Unity editor and do the first transition, but we also have to create another action before we do that, because yeah, if not, after the transition, our player will not do anything. So yeah, let's let him decide what to do and then move, heal himself, and that's it. So let's go back to the editor right now. So back in our editor, I just forgot something in the IDE. So let's go maybe quickly back to the IDE. I will do that right over here. In our StateSO, we do not call our check transitions function. So let's do that as well quickly. So here we just call the function and refactor the code. There we go. So what we do basically is, again, to recap, is we do run the actions, all the actions we have in the array. And we do run all the transitions. So we check whether we get, you can do multiple checks, whether we are getting attacked, or we have low health, or we press a button, or we have to die, or whatever. So all the checks will be stored in the scriptable object, or you should store them in your logic in those scriptable objects. And we will go through those transitions, and then whether the check, the decision is true or false, so whether you're dead or you are healthy or unhealthy or whatsoever, you transition to the true state or to the false state. All right, enough talking. Let's go back again to the editor and create some scriptable objects. So we have to create our decisions folder. So let's go and do that quickly. And right click onto decisions, create SOFinite State Machine decisions HealthySO. We keep the name as it is, and we have to create another state. We have to create the remain state. So whenever we do something, we have to remain in the same state. So we click right click, create SOFinite State Machine state, and we'll call it state underscore remain. And we will leave everything empty here. Why? Because in our entity, we have to drag and drop the state inside the remain StateSO, and that means that whenever we encounter the remain StateSO in our actions, right over here in our transitions, we will stay in the actual state. So let's check this out now. So if we click here, we say decision as a state, we put our decision state on top, the healthy check, and our healthy check says that as long as our health is bigger than 80, we're healthy, so we do remain in the state, right? So we stay in the same state. We can also do, is not null check, but if we do a remain state SO, we keep it pretty clean, and we can follow our states in the inspector pretty much better. And if the state is false, we do something else. We do transition to our state machine. If it's false, we transition to our false state. But at the moment, we have no false state. So let's start it as it is and see what happened. So our entity is running, and let's decrease his health pretty much more. Oops, I did it. There we go. So when his health is going under 80, he's not healthy anymore, and he transitioned to the null state, since in our false state here is none. It is null, so we transition to the null state. So what we still have to do is we have to go quickly to our action script here, and we create another action, and we will call it what a name? Let's say consume action, okay? Or yeah, let's call it consume action. That's fine. Consume action SO, and the consume action SO will be super simple written as well. Let's open the editor. So right here, the consume action SO will we will do the boilerplate. We will remove the boilerplate code, and we will derive from the base action. So as always, we will have to implement the act override action, and we will have to create the asset menu. In our case, we say ConsumeSO is the file name, and we will put this action SO also under actions, but we will call it consume action. Now, the logic from the consume action is also super simple. Since we have implemented it already, we just have to put it into this scriptable object. So we have to call our consumer script from our state machine and call the consume behavior, right? So our consume behavior already defines the logic, what should happen. We just have to pack it in our box, in our scriptable object box. So after we have done that, we go back to our Unity editor again, and we can see what will happen after we implement the new state action consuming, and how we transition back to the waypoints after we have done that. So let's go and do it quickly. And yeah, so now back in the inspector, we do create now our new action, create finite state machine action, and we call it consume action. And now we need a new state. This state will be, let's create a new state and call it, oh no, I have no name for that. Let's call it state consume, right? And the action we will run here will be the consume action. And then we have this transition here. And what we will put in here is, we'll check here as well if we're healthy, and as long as we're not healthy, we will do our consume act. We will run our consume state, or well, so we will remain in our state. Let's say it like that. So we stay at the food stand as long as we're unhealthy. So we wait until we heal enough. But if we're healthy, what we will do is we will transition again to the travel state. So we have now this endless loop of traveling, and if we're healthy, we remain, we keep traveling, and if we're not healthy, we do transition to this consume state. And whenever we're in the consume state and we're not healthy, we do stay in the state, because we run this consume action SO all the time, so we consume until we're full health. And whenever we are healthy enough, we go back to the travel state. So let's click on our entity, press start, and let's see how it's going, right? So we have here our health. Let me decrease it quickly as well, like that. Focus on the state travel. And whenever this happens, our health is under 80, we go back to the state consume. Then we consume, and we transition back to the state travel. And then we can also do the same thing again. Our health is smaller than 70. We go back, we recover. Of course, our health is higher than or bigger than 80, so we go back to traveling, and so on. So that's it. That's how simple it is. So now a small to-do for you: create the boxes script. It will be basically the same script, the same stuff, nothing special. That's a small to-do for you guys. And whenever you have done this, write it down in the comments down below how difficult it was, how easy it was. And if you have problems with it, in the description down below you have also the GitHub repo, so you can go there, check it out, and just copy paste or see how I have done it, so you can understand the logic behind it. All right, guys, thanks for watching. It was quite a long tutorial, and the next time we will do a more advanced scriptable state machine. But that said, I hope you have a wonderful weekend and have a good time, guys. Bye bye.